Hey everyone and welcome back to the channel. Today we are diving into something that might sound like a buzzword at first, but it's actually a foundational concept in software design: layered architecture. And we are going to look at it through the lens of C++. So what is layered architecture and why should a C++ developer like you care? Let's get into it. Imagine you are building a fairly standard application. Maybe it's a game, a business app, or a networked service. As it grows, you notice that your logic, your input-output, your rendering, your database access, they all start to blur together. You are editing files that talk to too many parts of the system. Changes in one place randomly break others. Debugging becomes a nightmare. That's where layered architecture comes in. It gives us structure. It's about organizing our code into logical layers of responsibility. Each layer has a specific purpose, and ideally, it should only communicate with the layer directly above or below it. So, how many layers are we talking about? Well, that depends on your needs, but most systems use 3 or 4. Presentation layer handles input-output, UI or user interaction. Application layer orchestrates operations like what happens when you click a button. Domain or business logic layer contains the actual rules of your system. Data access layer deals with databases, file systems, or external services. Let's see this with a simple example in C++. Let's say we are building a banking application. Our user wants to transfer money from one account to another. How can we lay this out? First, we will define the domain layer. This is the core. It knows what an account is and how a transfer should work. This layer should have no idea how the data is stored or where input comes from. It just defines what the system does. Now, above that, let's build the application layer. This layer uses our domain logic to coordinate tasks. This service fetches the accounts from a repository, applies the logic, and saves the updated data. We haven't implemented that repository yet. Hold on to that though. Now, at the top, there is the presentation layer. This might be a console app, GUI, web API, whatever talks to the user. Notice how main doesn't know what an account is doing inside. It just invokes the service. Now, let's go back to the data access layer. Here is where we define account repository, maybe as an interface. Then, we implement that using a file or a database. That's 4 clean layers. Each has a role. The main function doesn't talk to accounts directly. The accounts don't care how they are saved. The transfer logic only knows how to use repositories, not how they are implemented. So why does this matter? Let me give you 3 reasons. First, separation of concerns. Each layer focuses on one job. This makes the code easier to understand, test, and maintain. You can look at one file and generally know what kind of logic to expect. Second, loose coupling. We are using interfaces between layers, like account repository, to isolate details. That means if we later move from file storage to a SQL database, only the repository implementation changes. The rest of the system stays untouched. Third and final, easier testing. You can mock the data layer and test just the business rules. Or you can test the service layer without involving the UI. It's modular. That's powerful in large systems. This isn't magic, it's a design approach. Let's talk about its trade-offs. Layered architecture adds complexity. For small applications or quick prototypes, it might feel like overkill. Writing interfaces, abstracting repositories, this can be extra work if your project is only a couple of files. Also, if you are not careful, the boundaries between layers can start to blur. People might start calling data access from UI code, or mixing logic into repositories. Stick to the rule. Only communicate with adjacent layers. Another tip. Use dependency injection between layers. Instead of creating objects directly, inject them through constructors or factories. This makes your layers more flexible and testable. For example, like this. That means you could later replace repo with a mock repository when you need testing. See how clean that is? Also, C++ gives you the tools for this kind of architecture. Interfaces via abstract classes, ownership via smart pointers, modular builds with headers and separate translation units. But you have to practice discipline. C++ won't stop you from breaking the rules. Unlike some managed languages, there is no built-in framework for layering. It's all up to you how you organize your code. When should you use layered architecture? When your app is growing and you want to future-proof it. When you need testable code. When you have multiple developers working in parallel. Layers help define clean boundaries. When you are doing domain-driven design or building something with business rules that might evolve. But again, if you are writing a quick CLI tool or a script-style utility, it's okay to keep things flat. Use your best judgment. To wrap up, layered architecture is about separating your code into meaningful layers: presentation, application, domain, and data. It keeps each part of the system focused, testable, and adaptable. It's not just for web or enterprise code bases. It works beautifully in C++ too, especially when you value maintainability and clarity. Next time you are about to mix UI code with logic, pause and ask yourself, would this be clearer if I split it into layers? Chances are the answer is yes. Alright, that's it for this one. Thanks for watching, and if you found this helpful, don't forget to like, subscribe and check out the rest of the C++ series.